Hey guys, here's your awesomely high-tech wrap-up video over valence electrons, energy levels, and dot diagrams, okay? So here we go. Valence electrons. I tell you, they are the electrons on the outermost energy level. They determine the bonding properties of the elements, which are really important. In some of our classes, we talked about that. Some of you are going to be figuring that out today. Okay, so our valence electrons, again, are the electrons on the outermost energy level, and they're really important for bonding. So if you're looking at our energy level foldable, which is amazing, okay, they are the ones for carbon would have 4 valence electrons because in that second energy level, it has 4 electron dots. So your number of valence electrons for carbon would be 4 versus the number of total electrons for carbon being 6, okay? Next up, we're adding today this electron dot diagram. And the dot diagram has to have the element symbol or that chemical symbol surrounded by dots. You're like, woo woo, whatever rap. Well, we're gonna get what those dots are. They're valence electrons, okay? The dots represent valence electrons. Here's an example of how dot diagrams correlate to the electron configurations that you learned in class yesterday. So here's the example for oxygen. Our electron configuration for oxygen, you have your chemical symbol in the middle. You have this orange ring. This first ring represents our first energy level. On that, we have 2, okay, electrons. Second ring representing our second energy level. On that, we have 6 electrons because oxygen has 8 total electrons. I knew that oxygen had 8 electrons by looking at our periodic table, seeing oxygen, seeing the atomic number of 8, okay? I could also have checked my energy level looking at our foldable from page 52, which I don't have filled in yet, of oxygen. But this is what you should understand how to do from class yesterday. So 8 total electrons for oxygen. Now, this VE negative represents our valence electrons. The way I find my valence electrons are, I count the outermost ring, or electrons on the outermost ring. So 1, 2, 3, 4, 5, 6. Okay, so there are 6 on the outside ring. Therefore, we have 6 valence electrons for oxygen. So these are the electrons that are really trying to bond with someone because they want to get to 8. They want to fill this second shell. They want one here and it wants one there. So it's working really hard to try to fill that and become stable because elements and atoms that have a full outer energy level are going to be really stable, and that makes them happy, and that makes them stable, okay? So this is how you would then show your dot diagram for oxygen. Dot diagrams only have valence electrons. You don't show all the other ones. So in oxygen's example, we don't show these first 2. We only show the outside 6. And the way you do it is you put your chemical symbol in the middle. So we have our O. And then you place your valence electrons around one at a time until you have 4 all the way around. And then you go back and add a second one to the areas until you would fill to 8 if this was neon. But this isn't neon, this is oxygen. So we only have 6 valence electrons. So down here I have equals 6 VE negative, 6 valence electrons. Let's look at our next example, carbon. Okay, here's our electron configuration model that you learned how to draw yesterday. Symbol in the middle. First ring has its 2 electrons because first energy level can only hold 2. The other ones that we're going to be utilized all can hold 8, remember. First one, only 2, so 2 are there. Carbon, from looking at my periodic table, has 6 total electrons, right? So on this, we have 2 here, and then on the second energy level, we need to add our 4 for a total of 6 electrons, 4 valence electrons. So those outermost ones are 4. So then we come over and say, okay, let's make a dot diagram because Rap's telling us to. You put your chemical symbol here, and then you go around and add 1, 2, 3, 4. So there are our 4 dots that represent our 4 valence electrons for carbon. I feel like I have another. Okay, so In recap, for our wrap up, valence electrons are the electrons on the outermost energy level. They determine bonding properties. Our electron dot diagrams use the element symbol surrounded by dots that represent our valence electrons. I'm going to make a new one here for you. Well, no, I'm not. So that is our explanation of valence electrons and dot diagrams, which you're going to be working on in class today.